Good day, good morning, good afternoon, wherever you are watching my videos from. Okay, so previously we have talked about the center of a data set. Center means where majority of the data set is there. Okay, and we discussed the arithmetic average, which is the mean of a data set. We also talked about the median. 50% of the numbers are below the median, 50% above the median. We also talked about the location of the mean with respect to the median. If the mean is greater than the median, more numbers on the right hand side, it's skewed to the right. If the mean is less than the median, mean is here, here, median is here. Mean is less than the median, more numbers on the left hand side, extended tail on the left, skewed to the left. So we know this already that if it is right skewed, there is an extended tail on the right. If it is left skewed, there is extended tail on the left. That means many small numbers. So there is a lot of variability or spread in the data. Have you ever guessed or thought about how am I going to measure variability in a data set? So not only the center is important, but we also get a grip on the variability or the spread of the data set. So today we are going to discuss about the center of our data, about the spread or variability in a data set. So here I go. The simplest numerical measure of the variability is the range. You probably heard about the term range. Range is the spread, a simple measure of the spread of the data. Range is maximum minus the minimum, or as is indicated here, the largest value minus the smallest value. Okay. Measures of variability describe the extent to which the sample observations deviates from the sample. So when we talk about variability, we want to find out on the average how far each number deviates from the center, or what is the difference on the average of each number from the center or mean of the data center. The n deviations from the sample mean are the differences. X1 is an observation, X2 is another observation, X1 minus X bar is the difference of the number X1 from the mean. It is also called deviation, which is same as difference of the number from the mean. If X uh, is greater than X, so if the number Xi is greater than the mean, that means the deviation is positive. If, on the other hand, the number is smaller than the mean, then the deviation is negative. Okay. In general, the greater the amount of variability in the sample data, the magnitude is ignoring the signs of the deviation. Except for the effect of rounding in calculating the deviance, it is always true that if you take the sum of the deviations of the number from the center of all the numbers in a data set, it will be zero. Why? Remember the definition of the center or the mean. It is the point which balances the fulcrum. We are putting weights on each number on the number scale. And at the mean, the balance is balanced. If you put a fulcrum at the mean, it will neither, the left will not go down, the right will not go up. It is balanced. Hence, if you add the deviation of each number from the mean, on the left, these will be negative. On the right, these will be positive, but they all add up to zero. Sum of the deviations is equal to zero. So here is an example of McDonald's food. Okay, different countries, different prices. Sum of numbers is, this is sum of x, means sum of all the numbers is 33. Take 33, divide by 10 because there are 10 number, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 3.67. Okay. And then you find deviations from the mean. As you notice, the numbers, x values which are greater than the mean, the deviations are positive. The numbers, values which are less than the mean, the deviation is negative. But if you add the deviations together, you will get zero. This is no good. Sum of the deviations is zero. What do we do with that? No information. We are not able to get a handle on how much is the spread. We want to get a tight grip on it. How much is the variation? Because if we add the positive deviations to the negative deviations, again, numbers which are greater than the mean, the deviations will be positive. If the mean is over here, the numbers are over here, deviation is positive. If the numbers are here, deviation is negative. You add them together, it's zero. No good. Because the positive deviations cancel out the negative deviations. Instead of just considering the deviations, we square the deviation. Remember, square of a negative number, that is in parenthesis minus 2, if you square it, it's minus 2 times minus 2, positive 4. We square the deviation so that the negative deviation square become positive, as you observe in the fourth column, squared deviation. The advantage of squaring is the negative square deviation, square of a negative deviation is positive. And you can find the sum of the squares of the deviation of each number from the mean. That's a positive number. And then you find out on the average what is the square of the deviations of the numbers from the mean. You divide it. In the top equation, you're finding the sample variance. You're dividing it by sample size minus 1 to get the average squared variation. That's called variance. Average squared variation from the mean, you're dividing by sample size minus 1. Why are we dividing by sample size minus 1 instead of just sample size? Because first we use the data to calculate the sample data to calculate x bar, which is the sample mean. Sample mean. Okay. So we square the deviations, add them together, divide by sample size minus 1. And we divide by sample size minus 1 because the same sample data is used twice. Once it is used to calculate, at first we use the sample data, add up the sample numbers, divide by sample size to get the sample mean. Used it once, then again we are going to use the sample data to calculate this average variance. So in the second process, the second time around, we say we have lost 1 degree of freedom of the sample, and we divide, instead of dividing just by sample size, we divide by sample size minus 1. That gives you the square on what is the average square of variation of the numbers from the mean. And if you take the square root of the variance, you get standard deviation. Okay. So it is n minus 1, not n minus 2. I explained that we lost 1 degree of freedom when we first used the information to calculate the sample mean on the top or on the numerator. Then we are using it, the sample mean data, to find the squares of the deviation of the number from the mean. Add all the squares, divide by not just by sample size, but by sample size minus 1. Why? Because we say we have lost 1 degree of freedom. N minus 1, we have lost 1 degree of freedom from the sample size. That's the average variation of the numbers, square of the variations of the number. So variance is square of the variation from the mean. That's what variance. And if you take the square root of variance, you get the average variation from the mean. It's no longer square. You took the square root. This S is the square root of the variance, is the sample standard deviation on the average, how far a number deviates from the center. Okay. So what do we do with all that information? We got how to calculate the variance of a sample, sum of the squares of the deviation, divided by sample size minus 1. What does it indicate? Average squared variation from the center. And you take the square root of the variance, you get standard deviation, which is the average. Notice by taking the square root, the square term is gone. Now the standard deviation is an indication of the average variation, not variation squared, average variation from the mean. So if you have large amount of variability, you'll have large values of S square or S, and smaller amount of variability, small value of S square. Standard deviation is considered to be a more natural measure of variability. Square root of variance gives standard deviation. These are the notations. Always remember, when we are dealing with population, we'll replace the English letters in the symbols by Greek letters, such as Greek S square or Greek sigma square gives you the population variance. And square root of sigma square, sigma is the population standard deviation. Okay. So I explained to you the when we calculate the variance of a sample, we divide by n minus 1 because we have used the sample data once to calculate the sample mean. The data has been used once to calculate the sample mean. We lost 1 degree of freedom to calculate variance. We divide now not by n minus 1, small n minus 1. That is called degrees of freedom of the sample. So, interquartile range. Again, you can arrange the number in the set of numbers in going from the lowest to the highest and then divide it into 4 equal parts. Just like you have a dollar, you have first quarter, second quarter, third quarter, and fourth quarters. 1 quarter is 25 cents. You have only the lower 25% of the dollar. 2 quarters, you have the lower 50% of the data. 3 quarters, you have the lower 75% of the data. If you have 4 quarters, you have the entire data. So the first quartile is the lower quartile. The median is the 50th percentile, 50% below it, 50% above it. And the upper quartile, 75% below it, 25% above it. Okay. So what is interquartile range? It is the upper quartile minus lower quartile. That is 75th percentile minus the 25th percentile. What is the range of the middle 50%? 75% minus 25%. Number at the 75th percentile position, number at the 25th percentile position. Subtract, it gives you the middle 50%, and that is your interquartile range. Okay. So, okay, how do you do this set of calculations in your calculator? Again, we are going to enter the data in L1, but the first step is to clear the memories of the calculator, remove the existing data in L1. How do I do that? Second button on the top left, plus button on the bottom right over here, then number 4. Okay, clear all this on your calculator screen, hit enter. Done. Okay. Then you press the start button and one button. And let's enter this data. 1200. We are entering all the numbers in L1. We are typing one number, then enter, then the second number, and so forth. Every time after a number, we hit enter. 2300, 3200, 3300, 3800. 4000, 4100, 4300, 4800, 5500, 5700, 5700, 5800, 6000, 6300, 6800, 6800 twice, okay, and then 6900 and 7700. Okay, so we have entered 20 data in L1, 20 numbers here. Now the cursor, black rectangle, is sitting in the 21st row in list L1. So we are ready to calculate the mean, median, and all these things. So second, no, mistake. Stat button, stat, highlight calc on the top row. Then number one word stat, stat, calc, one word stats. List is L1, go down to calculate and hit enter. What is the mean? The mean is 4775. What is the median? 5150. Okay. Interquartile range, they're dealing only with the lower half and upper half of the data. Okay. But we are dealing with the entire data. So for us, Q3, Q3 third quartile is 6150 minus Q1, which is 3550, will give us the interquartile range, which is 6 2600. Q3 minus Q1. Okay, 2600. Yes, 2600. Q3 is 6150, 6150. Q1 is 3550. 6150 is the Q3 minus Q1 is 3550, gives you the interquartile range as 2600. That is, if you add 2600 to Q1, you get the Q3. So the range of the middle 50% of the numbers in this case is 2600. What is the median? 5150. What does it mean? 50% numbers below, 50% number below it, 50% above it on a number line. Okay. And what is the mean? The mean is 4775. Let's compare the mean with the median. Mean is 4775, whereas the median is 5150. So the median is slightly greater than the mean. That means slight skew on the right. Sorry, mean is slightly less than the median. Mean is 4775. Median is 5150. So mean is slightly less than the median. Slight skew on the left. Slight negative skew. Okay. So we stop here today. And if you have any question, please do not hesitate to ask me a question. And if you like this video, please give me a thumbs up. That really motivates me. I hope you stuck around me with me through the entire presentation. This was all about calculating the center of the data, mean, median. We also talked about the interquartile range, which is the range of the middle 50%. Third quartile minus the first quartile gives you the range of the 75th percentile minus the 25th percentile. Okay. We also talked about what is the meaning of the third quartile, 75% below it, first quartile, 25% below it. Okay. Median is the 50th percentile, 50% below it, 50% above it. For the 75th percentile, 75% below it. So remaining 25% is on top of it. And for the first quartile, 25% below it, 75% above it. Okay. Again, if you like this video, please give me a thumbs up. I really appreciate that. Really motivates me. Please let me know on your comment, where are you watching from? What do you like about this presentation? What do you want me to continue on? What are other presentations you want from me? I'll appreciate that if you drop me a small note. Okay, that really motivates me. And if you like this video, share with your friends. If you like this video, subscribe to my channel by hitting the red subscribe button and at the same time hit Do not forget, but hit on the red bell button. That will notify you every time I upload a new video. Thanks for watching. Take care. Have a nice day. And do not forget to check me out tomorrow. Bye. Take care. Have a nice day.